Hey guys, it's Vince. Today in this video, we are going to be looking at one of the most dangerous videos in my opinion, and that is where YouTubers are deciding to more or less hack together a electronic device for CNC robotics and then decide basically they want to sell it and of course market it to you through their channel. Now, I found these videos and it's really disturbing to me because there's a lot of telltale signs here that these individuals literally have no experience in what they're working with. They're more or less doing the trial and error aspect I've discussed in many of my videos. And rather than explain it in this opening, we'll just jump right in and you can see exactly what we're talking about, and we'll cover the science behind why what they're doing is a failure.
Okay, guys, we're down in the shop. We're taking a look at this THC that we assembled. So what we've done is we've taken the display, we've mounted it on a board. We actually have an Arduino Nano that's sitting inside here that we can see.
Okay, after going to Google and once again pretending that I'm unaware of what Arduino is capable of or best practices with Arduino, I just typed in applications for Arduino Nano. Now, you would have thought that these end users who are trying to build this device would have looked at this prior to assembling their unit. Now we look at this and we see that what pops up, the best Arduino Nano projects of 2023. You can test this yourself, guys. And you can see it comes up with smart home, color changing coffee table, amber light, air quality monitor, universal TV remote. It goes on, right? And I'm a big believer in looking for consistency. When you don't know anything about a topic, the easiest way to see if that topic is being covered correctly by whoever posted this information is to look for consistency. So we just scroll down, right? We'll go to Circuit Digest and we'll come over here and you can see Arduino Nano projects. Now I want you guys to see what I see. Where do we see that this unit is best suited? And this is at the most basic form for a plasma cutter torch height control system. We'll just keep going through. Okay, and once again, I'm doing this as a complete novice. And I'm also doing this in an engineer in the sense that I realize, and many of you are going to say it, not all applications for these units will be covered. That's true. But I just want you to pay attention as a layman, if you are a novice and you're trying to figure out best practice, look at what we're looking at here. Dog barking security system, how to measure water levels. I mean, these are very low-level electronic applications. These are not applications that would be used in a plasma cutting environment where we're dealing with high-frequency and low-frequency noises due to the shop environment they'll be placed in, and also dealing with the fact that you're using it for production. Because once again, and I've said this in all of my videos, no one is purchasing or using a plasma cutting system that I have ever been aware of in over 15 years online being a vendor in doing production CNC robotics to do it just to cut for a hobby, in the sense they make no money. They're doing it for production. And when we look at this stuff, DIY GPS speedometer, infrared remote decoder, I mean, we're not seeing anything in relation to what they're actually looking at. I mean, everything here is not even close. We're not even remotely close to what these guys are developing. Okay? But we're going through, and I'm just going through, and we're going through 8 pages. And again, this is it, guys. This is basically where you're at. So now we've gone through 2 sites as acting as we're a novice. I'm just backing out. And basically what you have is consistency. We see that this is an electronic device. It can be used for low-level type science project experiments or projects where, again, we're not in an industrial environment, and what we're looking at is for basic automation in the sense of a feature set. We're not looking at accuracy when cutting. We're not looking at using it to detect relays in terms of voltages. I mean, we are all over the place, but we're certainly not near a device that should be used for a production CNC robot. I think we can all agree. The interesting part is they didn't even do this research.
And then we just used a couple blocks here to mount some wires. We have 2 potentiometers on here. One sets the voltage limit, the other sets the tolerance of the limit. So all the wires you see here are just simulating traces on a PCB board. What we did is we just took a little perf board, and it's just used for experimenting with. So you can just plug your wires in wherever you want, and then you have to make a jumper out of a wire to form a trace.
I'm sure many of you can see where this is going, especially my subscribers who have been with me for some time and have reviewed some of my previous CNC fail videos. This is where the end user of a component decides he'll take it upon himself by using forums and look into the design and fabrication of electronics that he thinks he has a thorough understanding of. Let's see where this goes, guys.
So this kind of gives a little explanation on the board. So we've got our voltage divider. Our voltage divider plugs into the back of our low-toast CNC machine, and then it's 51-to-1, divides the voltage down.
Okay, let's look at exactly what he's discussing, because we see this done on a lot of these videos from these creators where they think they figured it out and are trying to go through and analyze what they've done to their audience to give them the idea that they know what they're doing. And here's the issue with what we're seeing right now in this particular instance. He fails to cover the detail that the leads of your voltage divider cable that are to be run to the THC should be very short from the plasma cutter. In fact, the THC itself should be mounted at the base of your plasma cutter. And why is that? Well, the main reason is that we make sure that we have a very little voltage swing, if any, so that relays on typical THCs will do their job in sending that signal to go up and down for your torch head. Now, you don't have to take my word for this. You can see once again, and I've discussed this in previous videos, direct from Proma, who manufactures THCs, this same principle, and it's a very, very critical detail that's usually overlooked. Well, to someone who understands this principle, he would have brought it to light immediately, because it's a critical detail that if we do have voltage drop at all, it's going to stipulate the Z-axis head going up and down when it shouldn't be, or potentially give you a false positive. This will cause issues with the cuts. Once again, why is this not being stated? Because he's a content creator.
And it sends the voltage into our unit, and then it's analyzed. So when this is running, we set a target voltage. And for us, the target voltage for 1/8 inch is around 92 volts.
So his audience watching this, hearing his target voltage for 1/8 inch substrate for them is 92 volts, assumes that they'll start with that themselves. And the problem with that, once again, is details, gentlemen. You need to understand variables. Are you using the exact plasma cutter? Even if you are, the odds of you having the exact same voltage is very slim. There are far too many variables to utilize a set voltage definitively across the board for everything with CNC robotic plasma systems. You will adjust these based on your particular substrate, your particular plasma cutter, and it can go on and on with different variables. So keep that in mind. When these guys talk, they never are definitive about these details that are critical because they don't know. Once again, they are content creators. They are making entertainment videos for you, and they're trying to dictate, I'm an authority. The unfortunate side is that so many people in his audience are listening to this, and then they go back to the forum and say, hey, I've used this voltage that you've recommended, and I'm not getting the results you are. And believe you me, I get contacted at least 4 times a week with these type of incidents, and I have to go back into variables. What you're dealing with CNC robotics is details at an extreme level, especially plasma systems. Make sure you understand you have to eat this elephant one bite at a time to truly understand it.
So we set 92 volts, and then there's a tolerance, and it'll send a signal back and forth to the Z-axis to keep the torch always at that 92 volts.
His explanation is once again only partly descriptive, especially to end users who are new, trying to understand how does the THC send signals to the Z-axis in which it would just go up and down by itself. Well, if we refer back to the user's document, which is the user's manual bundled with the THC Proma 150, it explains exactly what this device does and how it works, and it also is going to show you the intricacies in making one of these units, because it's not as cut and dry as this end user content creator would like to make it seem. You can see that it says the unit is a modern analog microprocessor plasma torch height controller that operates by analyzing voltage changes in the plasma source due to variations in height between the torch tip and the material being cut. The microprocessor makes determinations to raise or lower the torch based off of the strength of the voltage signal being read. It is equipped with an easy-to-read LED display, and then it goes on to the functions of the unit. But if you look here at the details of the internal componentry of the unit, it's pilot arc voltage neutralizer, protection system, which is responsible for removing spikes in the AC electrical flow, which can be caused by plasma source with contactless arc striking, HV/HF pilot arc generating a high voltage, or from surges coming from plasma cutters equipped with contact arc striking systems. Main arc voltage divider. While in operation, a cutter generates dangerous voltage levels. Unsafe for precision electronics, a voltage divider system is incorporated to reduce this voltage to a safe level. Now, once again, he's come up with his own version of that. A quick acting filter system removes any interference that may pass through a voltage divider. I know his unit does not have that. And it continues and goes on and on and on. But the bottom line here is, guys, know the details of what you're working with. Once again, what's actually happening here is a voltage differential is being sensed. We have a relay that goes up, a relay that goes down, that will send signals to your Z-axis to let that floating head get a signal to either go up or down based on that voltage fluctuation due to bends and warps in the metal. Now you understand it.
It's going to film the top of the stepper motor. We put a little mark on it so we can see how much it's correcting. So we don't know what's going to happen. We're going to give it a try.
Guys, it would really make more sense that they did the initial testing of a device they plan on selling prior to using it for content. And that's just pure logistics. Let's see exactly what goes on here.
We've got a random set on the voltage. We don't know where we're supposed to be. Well, I don't know if you guys could tell, but there was a lot of correcting going on. It was jumping around up and down. Started out high, went down. So we've got some things to take a look at.
Well, that's a point of honesty that we all can agree with. There are certainly things they have to take a look at, especially considering they never covered any of the details that I went over that are extremely critical when connecting any torch height control system, being shielded cables going to the communication of the device to the controller, on top of dealing with a voltage divider cable that should be mounted virtually inches from their plasma system. None of this has been covered. What about the grounding of the table? Was that properly implemented before they actually went and connected this unit to see how it would function? No. We don't know if that was done. The only thing we know is that they ran a test, and of course it's a pre-marketing ploy to hopefully iron out the bugs to try to convince their audience that they know what they're doing and that these units are for sale. Now, guys, what's really disturbing about many of these channels, and this one included, is that none of them include CNC electronics as far as being their profession. Their channels are always based around fabrication or some type of maker or 3D printing or something around that field. But it's so interesting to me how many of them think that you can just cross over into this field because somehow they've played with electronics enough to understand it at a level they delve, makes them an expert enough to do it on their channel and then sell devices that they're going to offer support around, hopefully, to their end users enough to keep them running. I want you to think about what I just said. It's absolutely terrifying. And we're seeing this grow more and more and more with the release of more robotics and AI taking over into this industry. This is what's happening. End users are getting a false sense of accomplishment because they get motion and they think, this is it. I've accomplished it. I can definitely word this to other people and they're going to understand exactly what I do and get the same results. Unfortunately, guys, that's not the case, and that's why many of my clients find me just by doing a Google search and by telling me the horror stories of what you're about to see. And to prove my point even more, we'll see where this is going.
So we're going to drive this crooked metal, and we're going to see what's going to happen now with this cut. Again, Jackson's going to film the top stepper motor to see what's happening during this. Hopefully we get a good result. Not sure what's going to happen.
Many of you may be wondering what my feelings are using 3D printed components on CNC plasma chassis, and the truth of the matter is I never recommend using any plastic components delving in CNC where tolerances are critical. It's not that they can't be used, it's that there are better substrates for these applications. And I'm speaking purely as an engineer in the sense that nothing will hold up like metal over duration, on top of the fact plastic melts. So we already know plasma torches easily cut through steel with heat, and essentially how could heat as a byproduct be good to have around plastic? It really isn't, guys. So again, we have to look at things in a logical format. I'm not saying there's not new composites out there that are extremely durable, as easily as durable as metal in some instances, but overall for longevity, I would highly recommend going with a metal substrate, and I would certainly recommend metal substrates when you're looking at tolerances that are critical. I cannot emphasize that enough, because another variable that's never discussed and never brought up when we use 3D printed plastic parts is what printer is making these parts. Meaning, how calibrated is it? Is it a positive negative tolerance that you've worked with, or is things just okay? Most end users that we see as makers, aka content creators, they just see the part as being printed and functional for what they need. Most of them are not going through and checking how critical those dimensions are. And I know some of them will post full videos showing, oh, look at how accurate my system is, this, that, and the other thing. The choice is ultimately up to the end user, but in best practice, nothing beats metal, period.
Welcome back to the garage, guys. We thought we'd shoot a quick video today to answer a few questions that we're getting from people about our THC, where we're at, and also clarify a couple things that people are having issues with. So the first thing we want to talk about is the THC. I've got a completed THC in my hands here, but unfortunately, doesn't work. We had a little problem with the design of the board, and we've got a second round of boards coming in shortly, and we'll be able to get those out for beta testing real quick. So I want to go through some of the issues that we've had and just show you a little bit about electronic development.
I really like the way he addresses his audience as they've had a little problem. They're addressing it, and now everything is going to be made okay. Let's watch where this second video comes into play, because we can already see that there's a marketing aspect to where this is going.
Well, guys, here's the actual THC that we've been using on our machine for quite some time. It's kind of a crude looking device here, but
I love the way he explains it's kind of crude looking. Guys, think about this for a minute, and I cannot express this level of detail enough. They've been using this on their plasma for some time. You mean to tell me you never thought to make this a more organized assembly prior to shooting a follow-up video? Think about that level of detail when it comes to CNC robotics. That is what you're dealing with this type of content. And I cannot emphasize that enough. There's only one word for it, and that's content. These are not professionals. These are people who are testing things to see what happens, similar to an experiment. And then when they get motion, or they get the device to act in a format that they were hoping for, that's when they say, okay, I can now produce these, and now they become a vendor. It is scary, guys. Be careful on what you're dealing with and what you're watching.
what happens when you do electronic development, you have to start out with what's called a perf board.
One has to appreciate the way he explains electronic development, yet he fails to recognize the elephant in the room, which is the USB connector that's going to his device for control. And the issue with that in CNC Robotics, I'll insert once again the email direct from Balzis from CNC Drive, the leading manufacturer in both USB and Ethernet type devices for control, reflects that USB is an unstable transport signal for signals that are critical to be stable when we're working with CNC Robotics. Now, you can take that for what it's worth. I've put it in numerous videos. I've discussed with numerous potential clients. If you want the most stable robot, you need to stay with Ethernet. Now, it costs more. It's well worth it. In a plasma robot, it's absolutely essential to use Ethernet because of the high amounts of EMI. You will have potential signal penetration much easier with these robots, and therefore what you're reading in this email direct from Balzis is even amplified more so because of the nature of the beast, so to speak, with plasma robotics. So please, guys, once again, look at the red flags.
So the next thing we want to talk about is shielding. You know, it's very important on all plasma cutters to use proper shielding. And the wire has to be shielded to make sure we don't get electrical noise throughout the machine. A couple of things that you can see if you have electrical noise. One, the Z-axis probe switch seems to be very susceptible to noise. And using open builds control, you'll see the Z-axis actuate on and off throughout a cut.
I'm wondering how many of you feel as I do that it's extremely strange. He brings up using shielded cable in a second follow-up video where they're discussing the problems with the device, when in the first video, it was never even discussed. Matter of fact, when they went through the initial testing, they never talked about it either. So what it tells me, and it tells many of you, is that he's obviously learning as he goes from the people that are giving him feedback into a genre which he really doesn't have that much experience in. So guys, I'm telling you, the writing's all over the place. We see these content creators doing this all the time. Once again, 2 or 3 months exposure to whatever field that they want to work in. They see profit potential. They try to jump on it and implement it immediately. Let's see where this is going, but it's definitely going down the rabbit hole I predicted.
So guys, on the machine, all the wiring on the machine should be a shielded, jacketed cable.
Okay, I have to correct him on his choice of cabling. He should be using double shielded cable, which utilizes tin braided copper along with a mylar foil. Now, mylar foil is not as effective as tin braided copper, as it's a mesh that confines the internal leads to act as a Faraday cage. It's much more effective, but both are essential to mitigate both frequencies of EMI and both high and low frequency. These content creators do not understand this. They also do not understand that utilizing standard shielded cable that is not continuous flex when you're using motor cables for this application will deteriorate the cable very quickly due to continuous motion inside of the cable chain. And most of my clients out there are just nodding their head because they understand this. As soon as a cable is in motion that is not designed to be in motion, it will flex the PVC or exterior casing of the cable and over time will deteriorate it and cause internal fracturing of the leads. You don't believe me? Do your own homework, gentlemen. I'm telling you right now, these guys are defining exactly what they know, and it really just doesn't pertain to automation.
Just like we did the drain wire. And now this drain wire with this ring terminal will get hooked onto the bolt here that mounts it. And that'll keep this grounded. And we'll do the same process on the other end. And in our schematic, it shows to hook that other end up to the common ground in the box.
He's claiming now to discuss a schematic on how to properly ground his motors. And what he's described is essentially a groundlet. And I'm going to tell you how he created it. So when you guys go to ground your shield drains, they should always go, in best practice, to the electronics enclosures ground bus bar, which is run to your earth ground coming in from your IEC power port. I've shown this in previous videos on IDS systems I've built using Gecko Pro drives. I will insert that here. You can check it out.
Motors. You can see all 4 of them right there. And then over here, I get a lot of questions on the grounding. as far as how a system is grounded. You can see our ground splitter right here. Ground comes into the system. Here's the shield drains coming right off of our GX16 5-pin connectors. They go right in, so they're sharing the same central ground point, which would be known as a star point ground. Again, it's got its label right here, comes down, splits, and goes right over to our power distribution block for 110 right here. Okay, so everything is on the same ground.
And the main reason this is because naturally that's going to give you one central point of ground. Now, what he's doing by actually placing a ring terminal to ground the motor makes absolutely no sense if he's grounding his CNC chassis. Why do I say that? Because if you're grounding your CNC chassis, metal is conductive. And that means your motors are conductive to your metal chassis. Now, in his case, that may not be because he's using plastic, because he's using 3D printed components. That adds an entirely different realm of difficulty to this entire equation. But the principle is the same. If his motor cables are properly shield drained to the electronics enclosure, they do not need to have a ground running to the motor itself. There's absolutely no point to that. Okay, and once again, if he has any differential in his chassis, it can definitely give you a voltage switch that will absolutely create a potential for a ground loop. So we don't want to do that. The grounding of the chassis should be a separate tool used to once again prevent EMI to the chassis. Then we also ground our shield drains coming from our cables to our electronics enclosure. Now, the ground should always be the same. If they are not the same, when I say the same, they're run to the same central location. So if you put a ground rod in, you'll be utilizing that ground rod to a star point ground, which is just splitting those connections individually to whatever accessories you have connected to the ground rod, because the ground rod would only allow a single connection otherwise. So if you don't understand what I'm saying, I'll put a diagram up from Lincoln Electric to show you how this process is completed. But rest assured, this is the ultimate defining factor in this entire video, and I waited to the end to show you this because it truly defines, once again, these are content creators, guys. And their knowledge is simply limited by whatever is passed down through forums. Buyer beware. Okay, guys, that wraps up another video. And once again, I want to thank all of my subscribers. You guys have great. All the support I'm getting for these videos, I cannot tell you how much I appreciate it. And like I said, I'll certainly continue doing it as long as it keeps helping you. There's always something to learn, guys. And the truth of the matter is that with these content creators having the ability to market whatever they choose, we are the only ones that can hold them accountable if the information they're providing is incorrect. So again, do your due diligence. Never take anything that anyone says for granted. Look it up yourself, double check, and I guarantee you'll make the right choice.